All right, so this is going to be our walkthrough for the homework assignment titled Classifying Discontinuities. We just got a few of these functions here. So we want to find the discontinuities and then classify them. So we should be able to find them really easily just by factoring out the denominator here. Right, this is x minus 5 and x minus 2. So we should see that x equals 5 and x equals 2 are the locations of a couple of discontinuities, right? Because they make our denominator equal to 0, right? And so clearly that has to be a discontinuity. Now, if we want to just get a general idea, we can also probably factor out our numerator here. We can see that the numerator is x minus 2x minus 3. And the x minus 2's would cancel if we were like trying to simplify this down, which tells us that we should probably have a removable discontinuity at 2. And then we should probably have an infinite discontinuity at 5. But we should be able to use a limit, and you need to use a limit to show this on the test. So first we'll do the limit as x approaches 5 of f of x, right? Well, that should just be, if I cancel out the x minus 2's, I just have 5 minus 3 in the numerator, which is 2, over 5 minus 5, which is 0. And we know that 2 over 0 is, as we approach 5, right? We're getting close to 0 down here. So this is like either a positive or a negative infinity, which shows us that x equals 5 is an infinite discontinuity. And down here, we'll do a limit as x approaches 2 of f of x. And we can see that the x minus 2 should cancel. Right, so this is just like a limit as x approaches 2 of x minus 3 over x minus 5. Well, 2 minus 3 is negative 1, and 2 minus 5 is negative 3. So this limit comes out to be 1/3. But we know that f of, what we're doing, f of 2 does not exist. And so if the function doesn't exist, but the limit does exist, we know we have a removable discontinuity. So we have infinite at x equals 5 and removable at x equals 2. All right, we have 1 minus cosine x over x times 3 minus x. So for this one, what we're going to do is we're going to note that x equals 0 and x equals 3 are both possible places where we're going to have a discontinuity here. And so we'll do the limits. We'll do the limit as x approaches 0 first of f of x, which we had a rule for the limit as x approaches 0 of 1 minus cosine x over x. Right? That equaled 0. So what we're going to do is we're just going to separate this into two different limits that are being multiplied together. And I'm not sure. I shouldn't put the bracket here. I should put the bracket out here. Right? Times the limit as x approaches 0 of 1 over 3 minus x. So this limit should be 0, because that's what the limit as x approaches 0 of 1 minus cosine x over x is. And then times 1 over 3. Well, that just gives us 0. But we know f of 0 does not exist. So the limit exists, but the function does not exist, which tells us that we should have a removable discontinuity at x equals 0. And then for our other one, once we do a limit as x approaches 3 of f of x, right? Well, we should just then get the limit as, or we don't have to do a limit, it's just 1 minus cosine of 3 over 3 times 0, which is just 1 minus the cosine of 3, which is just some number, divided by 0. Well, some number divided by 0 is either positive or negative infinity. And if the limit comes out to be positive or negative infinity, we know that it is an infinite discontinuity. All right, for our next one here, we'll just factor this all out. might as well factor the x out of the numerator, even though it doesn't, it's not necessary for us to complete the problem. But we will factor the x out of the denominator and see that we have discontinuities at x equals 0 and x equals -8. So we'll do a limit as x approaches 0 of f of x. And when we do that, we should see that the x and the x here can cancel each other out. And really, we just have 0 plus 4 over 0 minus 1 over 0 plus 8. Right? Well, that's -4 over 8, which is -1/2. But we know that f of 0 does not exist. And when the limit exists, but the function doesn't exist, it's a removable discontinuity. Then we'll do our limit as x approaches -8 of f of x. And to simplify things, we can still cancel the x's even though we don't need to. We end up with -8 plus 4, which is, -4. And we end up with -8 minus 1, which is -9 over 0. Well, any non-zero constant over 0, when we're talking in a limit, is just going towards positive or negative infinity, which tells us that x equals -8 is an infinite discontinuity. And apparently I'm so used to writing infinities, I wrote infinity over here instead of -8, even though I think I said -8, right? We're doing a limit as x approaches -8. All right, for this piecewise function, the first thing we'd want to look at is if all of the pieces of it are continuous on the domains given. And x plus 3, x squared plus 1, and x plus 1 are all polynomials. So they're all continuous at any value of x, right, for all real numbers. So I don't need to worry about them being discontinuous. But what I do need to do is check and see if where they match up, right, at -2, right, and at 0, if the limits from the left and the right match up. If they do match up, then there's no discontinuity, right, because the function is defined at both -2 and 0 because of the less than or equal to's. But if they don't match up, then we have a jump discontinuity. So we'll do a limit as x approaches -2 from the left of f of x, which we'll need to use x plus 3 for. So that's -2 plus 3, which is 1. And we'll do a limit as x approaches -2 from the right of f of x, which now we have to use x squared plus 1. Right? So that's going to be -2 squared plus 1. Well, that's 4 plus 1, which is 5. And since, of course, 1 does not equal 5, that tells us that the limits don't match up, the limit doesn't exist, and therefore x equals -2 has a jump discontinuity. From the left-hand side, it's approaching 1, and then it jumps up to 5 on the right-hand side. And so then we'll do the same thing with 0. We'll do a limit as x approaches 0 from the left of f of x, which will be 0 squared plus 1, or just 1. And we'll do a limit as x approaches 0 from the right of f of x, which is just 0 plus 1, which is also 1. And since the function exists at 0, and the limit exists because the limit from the left and the limit from the right are equal, we do not have a discontinuity at x equals 0. All right, and this is our last one here. We've now got a limit as x, we got a function that's a piecewise function. We're going to have to do limits as x approaches 0 from the left and the right, and limits as x approaches 1 from the left and the right. And we can see that 1 over x does have a discontinuity just inherent in it, right? X can't be 0. But we don't have to worry about that because that piece of the domain, x is less than 0. It doesn't include 0, so we don't have any restrictions to 1 over x on this domain. And the same with natural log of x. Natural log of x can only be done for positive numbers, right? And, well, 0 to 1 is all positive numbers, right? So, and we should be clued in, too, that there's definitely a discontinuity at 0 because the function never equals anything at 0. Like, it's just x is less than 0 and x is greater than 0. So always be on the lookout for that to be guaranteed that there's a discontinuity. So we can see, and I'm going to actually do the limit from the left and the limit from the right here just so we can see. The limit as x approaches 0 from the left of f of x is 1 over, it's 1 over 0, right? But it's 0 from the left. So we have a positive 1 over a negative number, which is going to be a negative infinity, right? A very small negative number. And if we do the limit as x approaches 0 from the right of f of x, well, that's just the natural log of 0 from the right, which we've talked about in previous problems and previous homework assignments, right? As we approach 0 from the right, natural log is going towards negative infinity. So since both of those are going to negative infinity, x equals 0 is an infinite discontinuity. And in fact, we don't really need to check them both. You could have just checked one or the other and saw that it was negative infinity. And one side or the other going to infinity or negative infinity is good enough to tell you that the discontinuity is infinite there. And then for what's going on at 1, we'll need to do limits from the left and the right. So the limit as x approaches 1 from the left of f of x is equal to the natural log of 1 minus 4. Well, the natural log of 1 is 0. 0 minus 4 is negative 4. And we'll do the limit as x approaches 1 from the right of f of x, which will just be 1 cubed, which is 1. And since negative 4 is not equal to 1, the limit from the left does not equal the limit from the right, and that tells us that x equals 1 is a jump discontinuity. And that is it for this classifying discontinuities walkthrough.